This tutorial will highlight the new features introduced as part of Release 2 of Oracle NoSQL Database. The tutorial assumes you are familiar with Oracle NoSQL Database terminology. Our customers requested better integration with Oracle Database and also with SNMP and JMX. They also requested more flexibility on programming languages, C was the most popular request, and support for JSON since it is used so frequently for data exchange. Let's first introduce the new features in the area of integration and monitoring. First is external table support. Through Oracle's external table support, you can access Oracle NoSQL Database key value pairs as if they are rows in Oracle Database. This allows you to issue SQL read statements such as select count star, where the results are obtained from Oracle NoSQL Database. Since select statements can refer to multiple tables, the query can be looking at both Oracle NoSQL Database information and data that resides directly in the Oracle database. To read data from an Oracle NoSQL database into an Oracle database external table, you define an external table with one or more location files. The location files contain configuration information related to connecting to the Oracle NoSQL database and formatting. One can optionally define multiple location files to allow for parallelism during data reading. Multiple location files can greatly improve performance. Multiple external tables are supported, allowing for multiple views of Oracle NoSQL database. External table support can be used to access data in the Oracle tools, for example, Exalytics or Oracle Database. One useful use case would be to load quarterly data to Oracle Database for further analysis. This action could then be repeated every quarter. Sample programs and JavaDoc are available. In a sample performance test we ran with 1K records, the external table throughput was 500,000 records per second loaded from Oracle NoSQL Database into Oracle 11g. The optional formatter class can be used for special formatting and filtering of the data for importing data into a specific Oracle external table. Let's take a look at an example. We have defined 3 external tables, which represents key value pairs that reside in Oracle NoSQL Database. Once we have defined the 3 external tables, the publish utility is run, which describes how to access the data in Oracle NoSQL Database. We can now access the data directly with SQL. Let's take a look at 2 sample queries. The first query, select star from genre order by ID, simply shows the first 20 genres sorted by ID in the Oracle NoSQL Database. The second query will utilize all 3 external tables. There is nothing in the SQL statement to indicate the source of the data is Oracle NoSQL Database. Let's take a look at the result. Here we see the resulting titles with genre from 1976. The SQL statement could refer to a mix of tables that are sourced in Oracle Database and Oracle NoSQL Database. The above query would work, for example, if the genre table was sourced in Oracle Database. You can run your existing queries against data in NoSQL Database without any change to the application and without knowing where the data is stored. With this release, Oracle NoSQL Database now has integration with Oracle Event Processing. With the Oracle Event Processing server, one can take streams of events and operate on them. Oracle Event Processing supports JDBC, Coherence, and now Oracle NoSQL Database. An event in Oracle Event Processing can be anything you want. From the point of view of Oracle NoSQL Database, Oracle Event Processing is simply a client program. Imagine a stream of stock prices. If a stock, say Oracle, goes above a certain price, we want to know if a certain customer, XYZ, has registered an alert for that price. This reference information, the customer XYZ, and what action to take for that stock price is stored in Oracle NoSQL Database. The Oracle Event Processing engine will repeat for all customers that may be interested in that event. Oracle Event Processing can use Oracle 11g, Coherence, and Oracle NoSQL Database in this manner. For more information on the Java server that supports Oracle Event Processing, please see the documentation link at the bottom of this slide. A Jena adapter for Oracle NoSQL Database will be released by the RDF product team. This will enable RDF data storage and Spark L queries on Oracle NoSQL Database. Resource Description Framework, RDF, is a standard for representing information that can be identified using a Universal Resource Identifier, URI. It is particularly intended for representing metadata about web resources, such as the title, author, and revision of a web page. An example is in a social media or e-commerce application to perform friend-of-friend operations. If Chris and Steve are friends, and Steve purchases an item, what should I recommend for Chris? In Release 2, the administrator can enable and configure SNMP. SNMP and JMX are common frameworks, protocols, that support administration in some popular tools, such as Oracle Enterprise Manager. MIB stands for Management Information Base. Examples of the type of monitoring information available include per storage node agent, the ID and the number of rep nodes hosted. You can also retrieve the current status and configuration parameters, such as cache size. Mount points. When looking at an Oracle NoSQL Database configuration, this is the sort of information you want to look at first. If monitoring the system, you can probe the JVM parameters while assessing whether to make some changes. You then want to look at performance events. So with SNMP, you can monitor performance events outside of maximum defined values. SNMP is often used to monitor multiple systems, performance, disk subsystems, so the advantage of SNMP and JMX is that your administrative tool that you currently use may be able to include Oracle NoSQL Database configuration and performance information. Since Oracle NoSQL Database supports SNMP, Enterprise Manager products can add support for Oracle NoSQL Database. You still have the ability to monitor Oracle NoSQL Database through the web-based administrator or the command line interface. For the exact steps to enable SNMP monitoring, please see the administrative guide in the documentation set, available at docs.oracle.com or directly in the Oracle NoSQL Database Kit. Another common framework you can use to monitor Oracle NoSQL Database is JMX. This option is available in both the Community Edition, open source, and the Enterprise Edition. JMX, open source and from the Java world, is simply another option for monitoring performance stats. Through the framework, a JMX client can subscribe to performance metrics, service change events, and notifications. The same data is available when JMX is enabled as for SNMP. Any administrative tool that supports JMX can add support to Oracle NoSQL Database. Monitoring can be enabled for one or many storage nodes. Please see the Oracle NoSQL Database Administrative Guide, available in your distribution after download, for further information on how to enable JMX monitoring in Oracle NoSQL Database. Let's now take a look at the major new APIs available in Oracle NoSQL Database. The existing Java API is still supported, of course, but in addition, we have added support for JSON schemas and a new C API for performing CRUD operations on Oracle NoSQL Database. Finally, we have introduced a new API that can greatly improve performance for storing or reading large objects. Release 2 of Oracle NoSQL Database adds support for JSON schemas. Avro is a serialization format that can help you develop your applications more quickly than if you serialize and deserialize the data yourself. Avro is used in multiple products such as Hadoop and other programming languages. Having a schema and serialization framework is advantageous when working with multiple programmers and other products such as Hadoop. Avro provides an extremely compact, schema-based binary data format. A JSON binding for storing schema-based JSON data is also included. With Avro, each value of a key-value pair is associated with an Avro schema created in JSON format and typically created by the application programmer. An advantage of using Avro is that the serialized values can be stored in a space-efficient manner. Avro has a number of primitive data types, including Boolean, int, long, float, and string. Data is automatically validated with the schema definition. If you are storing data from multiple import sources, the schema can help you ensure you normalize your data. Having a schema can help with rapid prototyping since the schema is enforced. Multiple binding types are supported. With generic bindings, the schemas are treated dynamically, not fixed at build time. Using specific bindings, named specific Avro binding, has the advantage of creating a POJO, plain old Java object class, with getter and setter methods for each field in the schema. The JSON binding, named JSON Avro binding, is easy to read or create JSON and also can interoperate or exchange data with other programs that use JSON objects. The raw binding gives you, the application programmer, the most flexibility. Low-level serialization is not performed. Schema evolution is important with large databases where you can't simply update every key-value pair in the store whenever you need to change your schema. For example, let's imagine we have a key-value record representing profile information for a user. We have a new requirement to add an alternate email address. The field is added and a default value is established. In the future, if a new key-value pair is added, the alternate email address is added. If the profile information is updated, the alternate email address is added. On reads, for example, displaying the profile information, the alternate email address may not have been updated yet, and that is fine. A default value can be displayed. This allows complete flexibility in terms of providing the updated field over time. The new C API allows a C application to perform CRUD operations on an Oracle NoSQL database. The C API also includes Avro support so that you can mix C and Java programs through Avro. If the application requirements require, one could write data with a C program and then read it with Java, or vice versa. So there is good interoperability between C and Java. Let's take a look at some sample code. The basic steps are to create a KV store handle, create a key value pair, and use the put method to write, the get method to read key value pairs. Given a KV store handle, labeled store, we're going to call the methods to create a key and value. Once you have the key and value, call the KV put method, passing the store handle and the key and the value. Other sample C applications can be found in the Oracle NoSQL Database kit. A new streaming API for large objects, recommended size greater than 1 megabyte to hundreds of gigabytes, is now available. Examples of large objects are audio files, video files, medical imaging files, MRI data. If you are storing large objects, you should use this optimization technique as it can greatly improve performance for both storing and retrieving. A large object is stored as a sequence of chunks whose sizes are optimized for the underlying storage system. The chunks may not all be the same size. Individual chunk sizes are chosen automatically by the system based upon its knowledge of the underlying storage architecture and hardware. Splitting a large object into chunks permits low latency operations across mixed workloads with values of varying sizes. The stream-based APIs serve to insulate the application from the actual representation of the large object in the underlying storage system. New methods were created off the KV store handle. Going through the slide, the delete LOB method deletes a large object from the store. The get LOB method will retrieve a large object from the store. The put LOB method and friends, if absent, if present, will write a large object to the store. The result of using this approach is that the smaller chunks can be stored across the KV store, multiple shards, depending on size. With the stream, you never need to materialize the entire object if you don't need it. Now that we have discussed the new API support, let's take a look at some Release 2 enhancements in the area of scalability and management. Release 2 enhancements in the area of scalability and manageability. For each of these areas, elasticity, rebalancing, and increased data replication, I will discuss a use case. As a result of an unplanned corporate merger, the currently in production Oracle NoSQL database will gradually see a substantial increase in write operations. The read-write mix of transactions will go from 50-50 currently to 85-15 in the future. The eventual workload will exceed the I/O capacity available of the available storage nodes in the Oracle NoSQL database configuration. In order to increase write throughput, more storage nodes will be added. This will allow for the creation of more shards, and Oracle NoSQL database will populate the shards by moving partitions, subset of a shard, to the newly created shard. The current configuration, as depicted in the slide, consists of 8 shards with 3 copies of each shard for a total of 24 replication nodes. There are 8 storage nodes currently in place, with each storage node hosting 3 replication nodes. 6 of the 24 replication nodes are displayed in the table. One of the copies of the data, replication nodes, in each shard is designated as the current master, green in the slide. The master services all write requests and can also service read requests. The replication nodes labeled as replica service read requests for that shard and also receive updates from the master to keep the shards in a consistent state. Should the master fail, for example if the entire storage node were to shut down, an election will be held and one of the other 2 replicas would be elected as the master. The Oracle NoSQL database would do all of this automatically and the application would continue servicing read-write requests normally. The NoSQL driver would be aware of the changes and handle the routing of requests to the appropriate master or replica. The client applications do not need to know where the master node is, or for that matter, what shard your key value pair is stored. Each storage node is configured in this example to handle multiple replication nodes, as shown in the slide. Notice that each storage node has only one replication node serving as the master. The system administrator at the company has calculated that by adding 4 new storage nodes to the existing Oracle NoSQL database configuration, that future capacity and performance requirements will be met for at least the next 24 months. The company must be able to expand the KV store, Oracle NoSQL database, while the application clients are still running. All of the data movement must occur as a background activity to keep the applications online. The system administrator, after setting up the hardware, adds the storage nodes to the Oracle NoSQL database topology. She can look at the resulting topology, storage nodes, replication nodes, shards, etc., to confirm it meets their requirements. Once they are satisfied with the new topology, they can also determine when they want to deploy the new topology in the background and while the existing application continues to operate. As partitions, chunks of data are moved, they are made available to the live system. Here is what the new topology will look like. The new configuration will have 12 storage nodes with the same replication factor of 3, 12 by 3. The number of shards will increase by 50%. When new shards are added to the configuration, Oracle NoSQL Database will populate the new shards with some of the data from the existing shards. For now, notice that the key value pair, whose major key is sue.taylor@oracle.com, before we expanded the number of shards, was located in shard 1. After deploying the new storage nodes and topology, the same key value pair was moved to shard 8. Data movement from long-running plans runs in the background and is idempotent. It can be run multiple times with the same result. It's also interruptible at any time. For example, the company may have a peak workload period during the day and may want to interrupt the data movement and then restart it after that peak period. It's also restartable. New resources are available within a short period of time, even while the new configuration continues to be implemented. Let's talk about rebalancing an unbalanced configuration. A company has a 4-shard Oracle NoSQL database in production with a replication factor of 3, meaning each shard has 3 copies. One of the copies in each shard is designated as the current master, green in the slide. The master services all write requests and can also service read requests as discussed in the previous example. The replication nodes labeled as replica service read requests for that shard, and also receive updates from the master to keep the shards in a consistent state. Should the master fail, for example if the entire storage node were to shut down, an election will be held and one of the other 2 replicas would be elected as the master. Imagine this Oracle NoSQL database configuration has been in production for a while, perhaps a couple of years. Without warning, storage node 1 goes down. Let's take a look at what the new configuration looks like while that storage node 1 is down. Here we see the impact of storage node 1 no longer being available. The client application continues to run normally, since Oracle NoSQL Database will elect a new master for shard 1, since storage node 1 is down, and will no longer send read requests for shard 3, again to storage node 1. Read requests for shard 3 will go to storage node 3 or storage node 4. If storage node 1 returns to operation in a few minutes, or later that day, a replica for shard 1, shard 2, and shard 3 will again be available on storage node 1, and all 3 shards will become consistent with their respective master nodes. But in this case, something more serious has happened to storage node 1, and the entire computer disk configuration needs to be replaced. The company orders a dream machine, which has much greater capacity than any of the 4 storage nodes in place. In the next slide, we will see the new dream machine in place. The new hardware is a much more powerful machine. 9 cores, 256 gigabytes of real memory, and multiple 400 gigabyte solid-state drives. The hardware will be a heterogeneous hardware mix once it is added to the topology. The new hardware replaces the failed storage node, and the system administrator of the company adds the new storage node to the pool of available storage nodes. Since the old storage node is not available, the new storage node is migrated by the system administrator, executing a migrate storage node plan while Oracle NoSQL Database is still running in production. After successful migration, KVStore continues to run. The result is shown in the slide. Looking at storage node 1, we see the replicas are back up and available for shards 1, 2, and 3. Looking at the topology, the system administrator decides he/she wants to appropriately load balance this configuration to take better advantage of storage node 1. Notice we have this high-powered storage node that has the ability to handle up to 8 replication nodes, handling only 3, like the older and slower storage nodes with less memory. The system administrator for the company takes advantage of the new physical topology planning functionality and changes the capacity of the brand new storage node 1 to 6. The capacity of the older storage nodes is reduced to 2. Oracle NoSQL Database will allow him/her to review the resulting plan before it is deployed in production. He/she then decides to run the new topology at their convenience and while Oracle NoSQL Database continues to run. During this time, Oracle NoSQL Database will move replication nodes from overcapacity storage nodes, storage node 2, 3, and 4, to undercapacity storage nodes, storage node 1. This is accomplished in this case by simply replacing a broken storage node. The total number of storage nodes was not increased, though it could have been. Here is the resulting configuration. Here is the resulting new topology. If the workload data requirements increase beyond the initial plan, more storage nodes can be added in the future. Also, the older storage nodes, 2 through 4, can be replaced with faster storage nodes. Notice in this example we did not change the number of shards, and there are still 3 copies of the data for each shard. The result is a configuration which takes advantage of the extremely fast new storage node. This can be confirmed by reviewing the performance statistics available for each replication node with the new configuration. In the third example, we will increase data replication by increasing the replication factor. A new requirement has been placed on an existing Oracle NoSQL database to increase the overall availability of the Oracle NoSQL database by increasing the replication factor and utilizing new storage nodes added in a second geographic location. This is accomplished by adding 1 replication node for every existing shard, 3 altogether. The current configuration has a replication factor of 3, so the final result will be 4 copies of each shard, 1 serving as master, and 3 replicas per shard. While the system is live, the administrator changes the topology to define the new storage nodes in the new location, which is Toronto, and the new replication factor. She can validate the topology and review it before deploying. As a side point, the administrator could validate several changes to evaluate alternatives and then decide which topology to deploy. Just like the other scenarios described, the data is automatically moved and partitions are made available as they are moved as part of a background activity. Meanwhile, the KV store continues to service the existing workload, starting to use the new replicas as they become available. Once the topology is deployed, a new replication node has been created and populated for each shard. We have increased availability by increasing the replication factor where the storage nodes are in another geographic location. We have increased read throughput capability with the new replication nodes for each shard, and the replication factor is now 4. In all of the examples we have seen thus far, the increased capacity is available without having to change the client applications. In fact, the applications continue to be available while the expansion occurs. These are just some of the new features now available in Release 2. If you are interested, you can download the kit now and use the available resources listed in the next few slides to help you get started. You can install Oracle NoSQL Database on your laptop as a first step, and by running a special instance of Oracle NoSQL Database called KV Lite, you can write a sample application in Java or C and test your application on your laptop. This is a useful feature during the development phase. The complete set of documentation for Oracle NoSQL Database is available online at the link listed, docs.oracle.com, and can also be found in the distribution kit. There are Getting Started guides, an administrator guide, Java doc, and sample applications. There is also a detailed FAQ which contains useful information that is kept up to date in the online version at docs.oracle.com. Other Oracle NoSQL Database tutorials can be found at either of the links listed. You can obtain support and follow online forum discussions regarding various questions asked by our user community by going to forums.oracle.com for Oracle NoSQL Database on the web. Responses to questions asked on the forum are made by the user community, Oracle support, and often by Oracle engineering. I recommend taking a look at some of the topics discussed. Thank you for watching this tutorial covering the Release 2 new features available in Oracle NoSQL Database. If you have another topic concerning Oracle NoSQL Database that you would like to see presented, please let us know by posting a comment on this site or sending an email to ron.cohen@oracle.com. If you have further questions, you are also welcome to post them on the OTN forum.